Okay, so this is part 2, a continuation of my explanation from the different video we just watched just now. So let's get to it. I'm not going to explain question 1A until 1C because more or less the same idea has been explained before in video 1. I'm going to go straight to question 1D. Da-da-da. Question 1D. Okay. I only want you to take note that the idea is still the same. It's the big shape minus the small one. But then because both are circles, you have to be properly identifying what the radius is for both shapes, big and small. So for the big one, the radius is 7 plus 5, which is 12. And the small circle, it's 7. So the working is very straightforward. It's pi r squared for both. It's just that pi 12 squared for the big one minus pi 7 squared for the small one. And this will give us the answer. Of course, you can use your calculator for this. It's 298.5 cm squared. Done. Okay, that's how we solve question D. So all in all, in the first section of the questions, they are all quite similar. It's just that question D is a bit different, so that's why I want to explain it. Okay, so let's move on to question 2. Some of the questions are interesting, I can see here. Let's get straight to question 2A. Okay. Okay, question 2A. I choose yellow. Okay, for question 2A, I want you to know that 16 represents the radius of the circle. So radius equals to 16. And then I want you to also see that the square is actually made of 4 right angle triangles. Wow, my drawing, wow. Okay, so that means it's 4 times 16, half times 16 times 16. Okay, I'm going to show you the working. So that means the strategy here is the circle minus the square. Okay, let's do the circle part first. So the circle part is a straightforward pi r squared. Okay, that's all. And this will give us 804.26, correct, to 2 decimal places. And for the square, wow, look at my square. It's actually made of 4 triangles. So 4 times, and you apply the formula for the triangle. Half times base times height. And this will give us 512. Okay, referring to our strategy just now, that means we have to solve the first step that we have planned already. So you just have to minus this 2, 804.26 minus 512, and this will give us 292.3 cm squared. Done. Okay, let's move on to the next question, question 2B. This is quite interesting as well, because the identification of the radius is the first thing that we should do before anything else. So the strategy remains the same. It's still big minus small. But it's just that now your big one, if you look at it carefully, the radius of the big one is this entire thing. which is 16. And the radius of the small one is 8, as given. Now, the big one is a semicircle. So, your working should be half times pi times r squared. And you minus this with the full circle for the small one. So, pi times r squared. Okay? And then this will give us, if you use a calculator straight away, it's 201.1 cm squared. Okay, we are done with this. Okay, next question that I'm interested to explain to you is question C. Now, so for C, it's basically a square and a sector. Now, you may be wondering, how do you know that it's a square? Number one, this is a 90-degree sector. That means this is the center of your circle. A big circle should be like this, and this is a quarter of it. If that's the case, from the center to the circle, we call this as the radius. From the center to the circle, we call this as the radius as well. So without even telling you that it's a square, you must be able to identify this. Okay? So what do we do here? So the strategy is the square minus the sector. Okay, now for the square, this is quite straightforward. It's 12.8 times 12.8, and this will give us which one is it? Okay, so 12.8 times 12.8. Okay, never mind this. I'm just showing you that. And then you minus this with the sector. And the sector, the formula is a quarter, because 90 over 360 is a quarter. And you times this by pi r squared. Okay? And this will give you 35.2 cm squared. Okay, done. Okay, so that's how you solve the first 3 questions from part 2. And now moving on, if you look at question E. Now, this one, the idea is still the same. It's big minus small. It's just that you need to know what you have to do is find the area of the sector. Sector minus the triangle. Okay, so if you look at the sector, so the working for the sector is a quarter times pi times r squared, and then you minus this with the triangle area, which is half times base times height, and this will give us 20.6 cm squared. Okay, sometimes some of you may confuse about which of the lengths that constitute the base and the height. Please do remember, if it's a right angle triangle, your base and height must be connected perpendicularly. You can't simply take this as either base or height, because it's not part of the lengths that's attached to each other, well, in perpendicular manner or 90 degree. Okay, so let's move on to the last question, this one. Okay, in this question, you know that both are semicircles, so it's quite straightforward. It's just that you need to label the radius correctly. So the idea is still the same, big minus small. And then for the big one, it's pi times r squared. And for the small one, it's pi times r squared 2. But then, because both are semicircle, you have to halve them, okay? And you find the answer for this. The answer is 678.6 cm squared. Okay, we're done. So all in all, different questions require different strategies. It also helps for you to always revisit the properties and characteristics of certain 2D shapes, because it will be applicable in your decision making when solving compound shape questions.